everyone, and welcome back to Atman Unlimited. We're continuing our dive into the rabbit hole, and as one of our viewers said, a rabbit hole with bees in it. And our first video, we're talking end mills, was received quite well. So in this video, let's talk about the actual cutting edge geometry. So with a lathe tool, you're typically only engaging one face of the workpiece at a time. But with an end mill, you're going to mostly engage two faces of the work at one time. For example, picture this as my flute of my end mill. So I've got a flute, and it's going to have a cutting edge down its side so that we can cut the peripheral of the part. And then it's also going to have a cutting edge a little bit on the bottom here so that we can cut the bottom of the part. Because typically, when we're milling a part that kind of looks like this. Okay? So we're going to have a bottom and we're going to have a wall. So the end mill comes in and it scoops material out, and it goes like that and, you know, fries our material out. So with that, we need to have two cutting faces that are engaged in the material at the same time. So that means we have to have two sets of geometries. Now, most end mills that you normally buy for softer materials and aluminum are positive rake angle. That means that the rake angle on both cutting faces are positive. You can buy all different combinations of positive, negative, and neutral rake angle cutting tools depending on the material you're cutting. Okay? So let's go into rake angle if you've never been exposed to it yet. So rake angle is the angle of the cutting face relative to the material. So if I have a neutral rake angle, that cutting edge is going to come in at a 90-degree angle to the material I'm cutting. If I have a positive rake angle, that cutter is going to come in at a positive angle relative to the material. So it's going to come out and kind of scoop the material out. Okay? It's going to cut it like a knife. Now, if I have a negative rake angle tool, that means that the cutting edge is going to lag the material and it's going to kind of scrape it out. Okay? So why would we want all these different cutting angles? Well, it has to do with the geometry of the cutting angle and the strength of the edge. So a positive rake angle tool will typically take less horsepower to run. However, because of the geometry of it, it's going to be thinner at the cutting edge and be weaker. So it's not going to last as long. That's why we use positive rake angle tooling typically on softer materials. A negative rake angle tool is going to be a lot stronger because it's going to have more material behind the cutting edge. So we typically use negative rake angle tooling for materials that are harder to cut. But they take more horsepower to run because instead of having a cutting action, they generate more of a shearing action of the material. Okay? So, notice with our example here, we can change the helix angle of the end mill without changing the rake angle of the peripheral. And then, depending on how the manufacturer does the bottom cutting edge, you can also, you know, make a little hinge so that you can change it without changing the bottom cutting geometry. So the bottom cutting geometry is the same. So right here, this would be a positive rake angle. If we straightened it out like so, that would be a neutral. And then if it lagged it, like that, cardboard's hard to bend, that would be a negative rake angle. See, it's kind of scraping the material off. Okay? So they have positive cutters, and then typically you'll see positive negative cutters, where the bottom portion of the cutter is positive angled, and then the side peripheral cutter is negative angled. Okay? So that's one thing to consider when you're looking at end mill geometry. So let's go down to the office and we'll take an up-close look at an actual end mill, and let's go over more of the geometry. Because there's also relief angles, we've got setter cutting, non-setter cutting, and we also have the hook and the flutes. So let's take a look at the rest of the geometry involved in the end mill cutting edge. So what we're looking at here is the end of a 1/2 inch 4 flute standard square end mill. Okay? Now this is a center cutting end mill. And the way that you can tell that it's center cutting is if you look in the center here, you'll see that there is a cutter face that goes from the edge all the way to the center, and then it repeats on the opposite side. Now, even though this is a 4 flute end mill, when we get near the center, notice that only 2 of the flutes are going to cut in the center. The other 2 flutes are ground relief, so they don't go all the way to the center. Okay? Now, with the end mill, with the end of the mill, just like with the sides, we have to have some place for the chips to go for chip evacuation. And that's what this groove is right here. Okay? So this groove right here is what they call the gash. And that is where the chips will go to be evacuated. Now, everybody says that you shouldn't plunge with end mills. And the reason why you shouldn't plunge with end mills is because they're not designed like drill bits are. Okay? So notice this gash, there isn't a good lead-in into the flute. The only distance you have to get into the flute of the end mill, which is right here on the side, is this little pocket area here. So the chips have to migrate all the way from this whole edge all the way out to get into the flute to then make it up and out of the hole. So that's why end mills don't plunge very well. Typically you want to do a helixal cut into the material and kind of, spiral down into it. Okay? So this is the gash. Now, also at the end mill, we talked about having a rake angle. So this end mill is a positive raked end mill. The leading edge of the end mill is leading into the material a little bit, so it's going to try to slice the material off. Okay? So that's a positive raked end mill. Now, we've got the gash and the rake angle on the cutting face. Now, after that, we need a relief angle because we don't want the end mill to rub on the material after it's cut. So end mills have typically 2 relief angles. They'll have a primary relief angle here, okay, and typically this is called the land, and then they'll also have a secondary relief angle after that. And the reason for that is all about this edge strength. We want a small relief angle here so that we can leave material to make the edge of this cutter stronger. And then after that, we want to taper off the relief angle, especially on the sides, so that we can get into the flute and make bigger flutes for chip evacuation. Okay, so that's the end of a standard square, and you can see it's square here. This is a very sharp end mill. There's almost no radius in here. Now you have to be careful when you don't have any radius because these corners tend to chip. But if you want to make a pocket that has very sharp inside corners, you need to use a square end mill. And I'll show you a couple of different end mills that have different corner radius profiles on them. Okay, so now that we've looked at the end, let's look at the peripheral, the side of the end mill. So this is going to be the axial rake angle, and the axial side, this is the radial side of the end mill. Okay, now just like the end of the end mill that we talked about, we have this rake angle here. Okay, and again, this is a positive end mill. So this angle actually kind of comes up and wraps around so that when it's cutting into the material, the angle is positive. Okay, then once we get into the once we get past the cutting edge, then we're into the flute. So this part here is the flute, and that's where your chips are going to go for your chip evacuation. Okay, and then after the flute, way down here on the bottom, this is called the gullet. Okay, so we transition from the cutting edge into the flute and then into the gullet. So then also on the back side of these, you'll notice, you can see there's also 2 relief angles on here. We've got a primary relief angle, so you can see it here in another land. Okay, and then we've got a secondary relief angle here that's much more obtuse. Okay, so again, we want this primary relief angle to be enough just so that we don't rub the cutter on the material we just cut, but we don't want it so obtuse that we sacrifice edge strength. So we want to leave enough material behind the cutter edge so that it stays nice and strong. And then we want to back off the relief angle a lot so that we can fall in and make a bigger gullet and flute so we get good, clean chip evacuation. Then, in addition to that, the more common things that you hear of is length of cut. So end mill, from the tip of the end mill to where the flute grind is done, that's the length of cut. That is the deepest you should ever cut with the end mill. Then after the length of cut, you'll have the overall length of the end mill, which is obviously from end to end. And then you'll have the shank diameter. Now the shank diameter can be a different diameter than the cutter. Okay, sometimes you'll get larger shanks so that you get more rigidity in the shank, and then the cutter is smaller than the shank diameter. In some occasions, what you might want to do is you might want to have a real short length of cut and then have a little bit smaller shank diameter, a necked down end mill. So then what you can do is you can cut a really deep pocket and only use a small amount of the end mill for your actual cutting, but then have a long shank that's a little necked down so that you can reach deep into that pocket. And what that does is that will increase your rigidity because you don't have all this material missing from the flutes. So then let's take a look at another end mill. We'll take a look at a non-center cutting end mill and see what that looks like. So here's another example of an end mill. Now this end mill is going to be a non-center cutting end mill. So notice we have this huge hole in the center here, and there's no flutes in here. So you cannot plunge this end mill. If you do so, it will bind up on the material in here because there's nothing to cut it. Okay. Now notice we've got these axial cutters here, so it will still cut the bottom of your material. If you want to plunge these end mills, you must use a helical ramp, and you have to make sure that your feed rate and your helical ramp angle are shallow enough to where you can allow this cutting edge to rotate around and cut the surface away before the material builds up and gets into this little pocket here. So you have to use a kind of shallow ramp angle when you're helixing these end mills into the material. Now this is also a roughing end mill, or some people call it a corncob end mill, but it still has all the same geometry. If you noticed, we've got the axial rake angle here, followed by the primary relief and the secondary relief, and then we have the radial rake angle, and then these are relieved a little differently, okay, because these are roughing end mills. Now the reason why we use these roughing end mills is about chip evacuation and chip buildup. So if you've ever used a standard end mill and you've done a real deep depth of cut that takes up almost the whole flute, or the whole length of cut here, what will happen is you'll get these chips that are really long and needle-like, and they tend to bird's nest up on you. So they're really hard to evacuate. Even when you're using a full flood coolant, they can still build up. So by putting these serrations in the flutes on the radial cutters here, what we do is we make it so that this ends up being like a chip breaker. Okay? So the chip of this end mill, the maximum chip size, is typically only going to be from the bottom of this cut to the bottom of this cut. So you get these little tiny curly chips that come off of these, and they're easy to evacuate with your coolant or your mist or whatever you're using. So you don't get the long stringy needle chips that are the full flute length like you would on a standard end mill. So they're easier to clean, or they're easier to evacuate the chips. Okay, so again, same stuff. We've got a radial rake angle, and then we've got a flute and a gullet. So that's our chip evacuation. So these are the exact same, they're just serrated like this. Okay, so let's take a look at what they call a bull nose end mill. Okay, so these are end mills that have a radius on the corner cutting edge. Okay, so notice on our other end mills, this corner was sharp, and it left a sharp corner in the bottom of a pocket or along a peripheral that we're cutting. Now this one has a nice radius to it. Okay, so now this end mill will leave a radiused corner at the bottom of our pocket rather than a sharp corner. Now these end mills are actually preferred when you're roughing or doing any other heavy cutting, because this radius in here really makes the corner of this cutter very strong. So it's less likely to chip or break on you. The other thing that bull nose end mills are really good at is shallow angle 3D profiling. So if you have like a ramp angle on a part that needs to be cut, you may not need to use a ball mill, and you can use a radius end mill instead, and then the radius end mills typically are a little bit more efficient at removing material than a ball end mill would be. Okay, so that's a radius end mill. All the other geometry is exactly the same, they just put a little radius on this corner rather than have it sharp. So let's take a look at a ball end mill. So here's a ball end mill. Now a ball end mill is going to be used anytime that you want to machine material off that is not at a perpendicular angle to your end mill. So you can machine slopes and curves and inside radiuses and all kinds of weird stuff with ball end mills, as long as the ball will fit within the radius that you're trying to go after. So ball end mills, again, they are exactly the same as our other end mills. They have the same type cutting geometry, except with ball end mills, they pretty much just wrap the flute and radial geometry right along into the axial side of things. Okay, and again, looking at the end, these two flutes are doing the center cutting, and these two flutes are relieved. Okay, so we're only cutting with two flutes in the very center. Now the problem with ball mills, and what you have to be careful of, is you've got this point in the center here that's basically a zero feed. So remember, the smaller the end mill you have, the faster you need to spin it to keep the chip load the same. So you've got this area in here that is not moving, but you're still feeding it, so it's got a really high chip load in the center. So you want to try not to cut with the very center of the ball mill if at all possible. And also think about, while you're doing a profile, if you're doing a ramp and you ramp from the high side to the low side, that's going to force this ball to cut on its center because it's kind of plunging it, right? So what you want to do is you want to cut from the low side to the high side, and then we're only going to be using, you know, up to whatever ramp angle we're cutting at. So it's always better to cut from low to high when you're trying to do profiling, to avoid cutting on the center whenever possible. There's situations where you're not going to be able to avoid cutting on the center. You just want to be mindful to minimize them as much as possible. Okay, so that's a ball end mill. You can see that the cutting geometry for an end mill is pretty complex. We've got all of these different angles and all these different relief cuts and the hook and the flute clearance and the rake angles. So there's a lot more to the end mill geometry than there is to a simple lathe insert. Typically you just have, you know, your rake angle, your relief angles, and then maybe a chip breaker. Okay, with end mills, typically we don't need a chip breaker because by nature, milling is an interrupted cut. We come in, enter the material, and then exit the material. So that automatically breaks our chip for us. So you typically don't see chip breakers when you're selecting end mills. Okay, so thanks for watching. I hope you found this informative. Like all the videos, please feel free to comment below. And I always try to read all the comments, and we'll take into consideration if I missed anything or anybody has something to add. We'll make another video on it so that we get, you know, the best library as possible. On the next video, I'm going to specifically concentrate on flutes and helix angles. So helix angles is pretty cool, and I don't think a lot of people give thought to helix angle. So stay tuned, and we'll see you on the next video. Thanks for watching.